Hello, ladies and gentlemen. Guys, Julian here, super happy to be with you. During today's video, we're going to talk about how insulin works in the human body. This is a great topic to explore. I want to keep the information that I'm providing you fairly fundamental, but I do highly encourage you guys to send me a private message or comment down on the comments below of this video if you have any specific questions regarding anything that I'm about to explain here. So let's get started, guys. We're going to use our model that we always use, Mr. Tom. We got Tom over here. As you can see, Tom has no body. We're going to basically focus on Tom's digestive system. And just to clarify things, this is not Tom's long neck. This is representing the esophagus. So why don't we start by going through the digestive system so you guys can have an understanding of how things are arranged and really have a picture of it, which allows you to understand the science of what I'm about to explain a lot better. It's easier to understand it that way. So here we go. Let's go through the digestive system. We start with the esophagus. That's basically down at the throat level. Then we're going to step right past the chest. We're going to find our stomach sitting right around here. So you have a good idea of where the stomach is. We're going to have their stomach. Next to the stomach, we're going to have the big guy. That's the liver. By the way, the liver is the heaviest organ in the body. Good information there. We have the liver right underneath, kind of like tucked behind the stomach and part of the liver. We have the pancreas. This is a big important one here for today's explanation. So we got the pancreas, then we go down to the intestines. We have the large intestine that surrounds the small intestines. We come down, we have our appendix down on that side, and then we have, of course, our rectum and our anus. And that completes the digestive system. So now let's talk about insulin and how insulin works, how it plays its roles in the human body, and why is it so important to consume the right foods that are not producing unhealthy levels of insulin. As we may know in today's world, type 2 diabetes, right? It's a very predominant type 1 diabetes. It's an unfortunate condition, and we'll get into that here in a little bit later. But this is what this relates to, amongst many other things. So let's go ahead and use an easy example here. We're going to say that Tom went ahead and Tom is about to eat. It's feeding time. So he just had lunch and he's craving something a little bit sweet. So let's go with a slice of cake. Here's a slice of cake. That's the best. Wow, that's really not that good. It looks like a slice of pizza. Pizza works too. So we have a slice of pizza, okay? Tom is going to eat the pizza. After its mouth, the pizza is going to travel down the esophagus. The first stop that the pizza makes is down at the stomach. The stomach is going to metabolize these foods. And to put metabolizing in simpler terms, it's going to break it apart. It's going to turn it into little bits of food in order, and that's via gastric acid, correct, in the stomach. It metabolizes the food, it breaks it apart, and then the food, this slice of pizza that we just consumed, is going to travel down to the small intestines, okay? Down at the small intestine area, and part of the digestive system, what happens here is that there is going to be a lot of blood vessels running across, interlaced all over the small intestines area. The job of these blood vessels is to absorb the nutrients that came from the food. Now remember, the stomach has metabolized some of those foods, so it's easier for the small intestines to grab it and start the absorption of nutrients and absorption of everything basically that we just ate. Now, in regards to the absorption of nutrients, this is the next important part here, is that we're going to grab these nutrients and we're going to focus on glucose, okay? So we're going to focus on, we're going to write it down here, glucose, and glucose would be sugars, or anything that turns into sugars comes from a sugar. So we're talking about starchy carbohydrates, we're talking about sweets, we're talking about fruits, we're talking about, again, fruits are natural sugars, so we're talking about crackers, alcohol, any of those will turn in the body into glucose. So once we have glucose absorbed by these blood vessels located in the small intestines and the absorption happens, now we have glucose. I'm going to make a little track here. Think about a track and field. We're going to make a little track, and this right here internally is going to represent my bloodstream. So now glucose goes from the small intestines right into the bloodstream. These little dots are going to represent the glucose, okay? Now glucose is flowing throughout my entire body. I just consumed the cake, got metabolized. Glucose is out of the small intestine area and into the bloodstream. So now what happens when glucose starts to circulate, it stimulates the pancreas, okay? The pancreas, remind you, is located here, right behind, kind of like tucked in underneath the stomach and next to the liver. We have our pancreas, and pancreas is going to secrete, by the stimulation of glucose, is going to secrete something called insulin. This is the big one here. So insulin is a hormone, and the hormone of insulin produced by the pancreas is in charge of lowering your blood sugars. That's basically its a major role amongst many other roles and functions that we'll get to here in a little bit. So pancreas producing insulin. What does insulin do here? Insulin comes down, okay, to the glucose, right? We're going from pancreas to the bloodstream, sending those hormones of insulin. And what is insulin going to do in the bloodstream? Is going to help clear glucose from our bloodstream. Now, here's a piece of information that is very valuable. Glucose is toxic in the human body. If it's not stored properly, if it's not dealt with, if the insulin doesn't come and does its job, then glucose becomes toxic in the human body. So here comes insulin to get rid of glucose. Now, where does insulin place glucose? Well, it has a few choices here. It has 3 places to go to. There's only 3 cells in the human body that will absorb glucose with the help of insulin. We have liver cells, muscle cells, and fat cells. Now, liver cells and muscle cells, the skeleton muscle, is going to store this glucose as glycogen. Now, glycogen is going to be our primary source of energy. It's energy that is ready and it's available. So that's where the glucose from our bloodstream that can be put to good use basically and made available for energy. And most often this type of glucose is going to come from healthier complex carbohydrates or healthier sources of sugar, okay? But then if we have an excess of glucose, we already transported some, it became glycogen, but I still have a lot of glucose floating around. So my pancreas is secreting insulin to deal with that. Where does the glucose goes now? If it's not going to the liver cells and the muscle cells to become glycogen, it will get stored in the fat cells, okay? And actually, let me write it down here. This becomes a lipid. Lipids is that storage of glucose into the fat cells. That becomes a lipid. Okay, so if it goes to liver cells and muscle cells, we can make it for available energy. If it goes into the fat cells, it becomes a storage unit. Now, what's the issue here with insulin? How is it such a sensitive topic of discussion? Why does it affect so many people? Well, here's the deal, guys. In order to make this a little bit simpler, if Tom was not having the slice of cake or the slice of, maybe an apple with a bunch of honey, doesn't have to be necessarily a bad choice. It just has a lot of sugar, a lot of glucose in it. But instead of that, if Tom was having a avocado toast with some whole grain bread and some avocados, majority of those fats will go to glycogen, will go to places like the brain. The brain is another place that has absorption of glucose. So those become very efficient energy sources because they get utilized right away for walking, for talking, for breathing, for going to exercise. Of course, if you're an athlete, all my endurance athletes here, all my professional athletes, my guys that are coming up, and my girls, I have more girls than guys, professional athletes that are coming up. This is where you want to focus on. You want to make sure that you're consuming foods that are storing glycogen and not storing so many lipids. So that is the big difference there. So allow me to quickly focus on this fat cell. And I'm going to make one small, I'm going to get rid of our bloodstream. We already know that the glucose has been transported out of there into either one of these cells. Now, let me go ahead and focus a little bit more on this. This is what a fat cell looks like in my head. So it's a poor representation. It's pretty hard to draw one of those. So we have a fat cell right here. Now, something that the fat cell has is a receptor. It's got a receptor for insulin, okay? Now, this insulin, remind you, is bringing the glucose from the small intestine into the cell. Because enough was already stored as glycogen, there's an abundance of glucose, so now guess what? It has to go to storage. Majority of the storage goes to our lower belly area, visceral area, and that's with the intention of protecting our vital organs. You know, the human body is extremely smart and adaptive, so it protects the human organs. However, an accumulation of that will give you high levels of body fat percentage, okay? And that's not good for your health. Accumulation of that will start to go to the arteries. Now we're talking about cholesterol. And here is the most important one. When there is too much of this little guy's glucose, okay? And the body, the pancreas, has to continue to secrete insulin in order to grab them and store them. Eventually, this receptor will no longer respond to insulin. That's what we call insulin resistance. That is called type 2 diabetes. Type 1 diabetes is when the pancreas itself does not produce any insulin on its own. That's type 1 diabetes. That's more of a genetic condition. Type 2 diabetes, environmental condition. Because depending on what we do here, is going to give my body the signal and the outcome of either storing a lot in my fat cells or making most of it available for immediate sources of energy. So that's the big importance there with insulin. And I want to finish up, guys, by simply providing you a few functions, not pros and cons, but functions, benefits, and how things can go wrong with a large secretion of insulin, which is caused by a large consumption of sugars, correct? As we have understood. So allow me to make a little bit of room here. Okay. We're gonna just need that right there. And what I'm gonna do is I'm gonna write down some of the most important things about insulin. So let's write down here insulin. And like I say, I'm very rusty, so I apologize if my handwriting is way off. I would say that the most important one is the lower blood. Oh gosh, I made a mess. Blood sugar levels. Okay, it lowers blood sugar. I would say that another thing that is very important to know about insulin is that it can prevent the burning of fat. It doesn't allow, it prevents fat burning. So you'll notice that a lot of people that suffer from some sort of condition where there's insulin resistance, they have a very, very hard time losing weight. It's because when there's insulin present in the body, there's gonna be very, very little fat burning going on. So we got that. Huge one here, amino acids. Very poor absorption of amino acids, which are blocks that build protein, very important for muscle tissue. Very, very poor absorption of amino acids when there's an abundance of insulin flowing through the system, trying to get the glucose to go places. Basically everything that we just talked about. So there's a big depletion in the absorption of amino acids. Potassium suffers from the same condition here. Potassium gets affected, it doesn't get absorbed. What happens when potassium is very low? Blood pressure goes all the way up. I'm at risk of heart attack and many other things. And last but not least, let me give you one more here. We got lowers blood pressure, prevents fat burning. Oh yes, and it retains sodium, insulin. That's why, guys, when we consume something that is high in sugars, and it's not good for us, all the bad fats, everything that goes into fat storage, we're going to lose muscle, muscle tissue, so you're gonna be weaker. Your potassium is not gonna be absorbed, it's not gonna be optimal levels, so you're gonna have high blood pressure. So here we go, we're weak, we have high blood pressure, and on top of it all, there's a extra production of sodium. Sodium causes the body to retain water, so now we are very weak, high blood pressure, which makes me feel awful, and we have a retention of water. Those are the bad things about big secretions, large production of the hormone of insulin by the pancreas. Guys, again, I'll cut it here. Any specific questions, please let me know. I would love to dive into them. I would love to help you personally. And yes, I welcome and I encourage everybody to comment. I hope this was helpful. Regarding insulin, we're gonna thank Tom. Thank you, Tom. He's always great. You know, he's always got different hairdos and a very long neck today. That esophagus. I hope you guys enjoyed. I'm super happy to be here again, and we'll see you guys soon again, okay?